Well, hi and welcome to my shop here. It's January 27th and I'm getting ready to do some more alignment work on the radio here. This time we're going to do the upper IF, the 3955 IF. But first, although I don't want to turn my channel into anything other than a radio repair channel, there is this thing about the virus going on. I'm going to give you a little update about the situation here, because in a matter of a week, where I live has gone from being a relatively safe place, relatively safe place in Canada, to potentially one of the most dangerous in just a week. So how can that happen? I'm going to put a map up while I talk here, just for a few minutes, and just tell you what's happened in my area here. Here's a map of North America, and I live right here, right here. Just zoom in. Here's the big city of Toronto. About 3 million people live here. There's a heavy population all the way around the lake here. Millions of people live right in this area. You come north from Toronto, about 1 hour drive, you get to a city called Barrie. Barrie has about 125,000 people in it. And then if you drive another 15 minutes along this road, you come to Orillia, where I live. And in fact, I live right here where the little house thing is. 30,000 people in Orillia. What's happened in Barrie? So in Barrie, there's a long-term care home that about a week and a half ago or 2 weeks ago, they started reporting a lot of COVID. And what that's amounted to in the end, today they are suggesting there's 100 people in Barrie who have the UK variant, and it's out of control. This is the word today. Yesterday, out of control wasn't really talked about. They're not using that term, but it's quite clear that's what's going on. They can't contain it when you have a long-term care bill. I don't know where it is. It's somewhere in the city here. You have a long-term care operation with 100 people. That includes people who are there, living there, and people who are there taking care of them. You have to assume it's gotten into this community already. It's a 15-minute drive. People live in Orillia and work in Barrie and drive back and forth. Now we're all under stay-at-home orders, work from home and all that kind of stuff. So the amount of interaction between here would be minimal, very minimal right now. Normally there's a lot of people going back and forth here. My wife and I regularly go to Barrie to do shopping and stuff like that. Well, we don't now. So there's a long-term care home in Orillia which has an outbreak right now. Which COVID it is, no one knows at the moment. The tests are literally in the lab today, being tested. So in a day or two I'm going to find out. Potentially there's a long-term care home in my city full of the UK variant, and if it's here and it's here, it's everywhere, and it's also here. It has to be here too. It just can't be the case that it's isolated up here. So that's the situation. If you haven't read up, or if you're not aware of what I'm talking about, the UK variant is about, by Canadian estimates, about 50 to 80 times, 80%, not times, 80% more infective. That difference doesn't sound like much, but it's the difference between being able to control it and being not able to control it. That's what it looks like. If you get a virus that's infectious enough, you can't control it. People can't live their lives 100% out of contact with each other. We can't do it. We have to go to the store and stuff like that. So there's some transmission going on, even though we're all at stay-at-home orders. Anyway, that's the situation. I don't want to dwell on it. This is going to change very rapidly over the next couple of days. So I may, in a future video, spend a little more time talking about this. But for now, as always, my wife and I have treated this situation as if it's a 5-alarm fire. We assume if we get the virus, we will die from it. We assume that because it's very motivating. We don't go out. When we go out, we take all the precautions. We minimize our time. We've talked about this in some detail. I've made myself aware by watching videos of people who know what's going on. By the way, there's a fellow in the UK, Dr. Campbell, who I've watched a couple videos. I had one sent to me from one of you to look at of Dr. Campbell in the UK, and he's the one who put me onto this just in the last day or two by watching one of his videos, how critical this UK variant situation is. Really, really critical. So that's the story. Again, let's get back to fixing radios here, because I don't want to turn my channel into some virus news channel. So in the past, I've probably done alignments that have gotten close. Maybe not in the case of this adjustment here. And close can be okay if you're listening to fairly strong signals, stuff like that. Close should be okay. So I'm going to stop now. I'm partway through getting this radio ready for this. I'm going to finish it off, and we'll do the try. I didn't read the alignment instructions yet. Wait a minute. Hammarlund seems to be very proud of their 3.5 megahertz oscillator, because they suggest it can be used as a frequency standard. Right here. Let me just make that a little bit bigger. The 3.5 megacycle crystal used in the second conversion oscillator circuit is held to a very close tolerance and may be used as a frequency standard at multiples of 3.5. In order to do this, in view of the complete shielding against radiation from this oscillator, it will be necessary to temporarily connect a 2-foot length of insulated wire to the antenna terminal and dress the free end around the tube shield. So what you're going to actually do is you're going to listen to the oscillator, or pick up the oscillator and its harmonics using the radio itself. The suggestion here is that this is exactly on 3.5. Okay, back in business. Thought I heard a voice there. Not hearing voices. Pin 7. Pin 7. If I get it close, you might be able to hear it. No. Signal level is maybe a touch too high. Coming in on pin 7. There it be. I do hear it. And we're lucky, when I was spinning the control over here, I didn't de-align the radio to the point where it can't hear anything anymore. Because once you get to that point, you might have to take a lot of little steps to get everything back into alignment. So let's go see what happens now on 31 on the meter. Now we're cooking. Well, I got it pretty close, just winging it. 33. It's a little out. And 34. Maybe just a touch out. Uh-oh. Well, that's correct. 3955 is the frequency we want. Yeah, that's correct. That's correct. So that is done. That was an awful lot of fussiness over a very, very simple process. Now we're getting into the more difficult one. I think we've done all the IF alignment. Now it's a much more difficult alignment involving the big capacitor here. We'll take a look at it. I'll take the top off. We'll look in, and I have to stick a tuning tool like this way down into the radio through these little holes here that are right over here, like this. You're going down this hole into somewhere down there, or down there somewhere. With the radio operating, I'm going to take this top plate off. Let me just see if the radio it drifts around or drifts off somewhere. Let's pull this top plate off now and see what wonders are underneath here. So it didn't seem to make a hill of beans difference on the radio. That's what's in there. That's a lot of capacitors. 1, 2, 3, 4, 5, 6, 7, 8 of them in there. It could be it's really 4. and the sections don't represent something separate. If you look way down there, you can see lots of wires and business going on. Yikes. Okay, interestingly enough though, it didn't make any difference to the operation of the radio. These are all aluminum parts, I'm pretty sure. Yep, no steel in them. So their effects on the radio maybe are reduced because they're aluminum. So that's it for the IF alignment. I put that tube back in place, and next thing we're going to do is, I don't know, what's next? What's next? So I'm preparing to do the next alignment step, which has to do with inserting a tool on an angle, just like you see the screwdriver here, down in there through these holes on about this angle. Feel your way down into a kind of a socket arrangement, and then down in the bottom of that is the screw, and hopefully you fall right into it. I'm trying to figure out which tool to use. See, I like to use something really stiff, not like this. This is too thin, and it's quite twistable. If there's any resistance in these screws or adjustments, I end up loading, tension into this, and you'll have a very bad time, which is why I'd like to use this big, thick, stiff one, but I don't think it engages. Seeing in there is a major problem. That's why I have the bright light here. I have the camera there. I was trying to see if I could see the engagement. The only other way is to have the radio operating, try to engage this, twist it, and see if you actually get it into the screw. It doesn't feel right. It doesn't feel right at all. This guy is engaged right now, but look, it's a big metal screwdriver. In the past, when I've aligned this, I've done it with a screwdriver like this, only a sewing machine screwdriver with a long shaft, a lot less metal. I lost that screwdriver ages ago. It was my favorite screwdriver. So this would do it. But all that metal going in there, I think from experience, I know as you push it in, the radio tunes. So we really need to use something like this. Let me stick this one in there. Okay, it's seated. Like it's gone into the thing there. So I think this is going to work. I'm pretty sure I'm turning the screw a bit, and it feels good. Doesn't feel like it's sticky or jumping. Like if you use a soft implement here rather than a solid piece of metal or something, and the thing you're trying to turn has some resistance in it, friction in it, that you have to overcome, then you're gonna do this. You're gonna load up your tool, and then it's gonna go pop, pop, and then oh no, I want it in between. You're gonna try to go back, pop, pop, and you can feel it very distinctly in the tool. Can't have that. You'll drive yourself nuts trying to get it to stop on the right spot. So you need a very stiff implement, which I don't have. Okay, that's step one. Get the tool in there. So we're going to read over the instructions together here before I get into this. Just one thing that you just may not be aware of is every time you do a band change, a whole new set of inductors and capacitances show up through this hole. So you adjust all these, change the band, adjust them all again because it's a new set. That turret is rotating all that stuff inside here, just in case you don't realize that. So let's take a look at the instructions. Alignment of the RF amplifier and HF oscillator. Don't quite, yeah, HF oscillator, right. Automatically aligned, blah blah blah, use the table, blah blah blah, put 100 ohms in the antenna circuit. So I'm not going to do that. I have a different way of matching the antenna to my signal generator, which is, I'm sure, just fine. This. Settings. I need to do all these settings. I'm just reading through it quickly here. And this gives us this band, you adjust the L at this frequency, you adjust the C at this frequency. So the first one, oh, I had this playing all this time while I've been talking. Want this out. You can't have the tool in and change bands because the band will pop the bottom. Band change will rip the bottom of your tool. Your tool will jam the band change process. So we want to make sure we're on the right band to start with. It's pretty easy to do. There we go. Liable to be some noise in my shop there. Okay, first frequency. We don't need all that hiss in the ears. First frequency. So 0.56. We need to put 0.56 on here. 5.5, 5.6. So now we need the signal generator running at 560 kilohertz. Ah, don't need this light here. The box here either. That's going through the IF. So if there were to be an IF signal out here, just in space, getting on your antenna, it's going to come right through this radio. Come out the speaker. Doesn't matter how you tune it or anything. I think there should be a trap on it somewhere. Gives you an idea how close this radio is right now. So there's 0.56. The signal on the meter here. We're at the low end, so we're doing the L. The holes here are labeled with a C, L, C, L, C, L. Is it the same all the way? Hard to see. C, L. Yeah, they're all the same, of course. Good. So the first one we got to get into is this one. And you see it's interfered with by this bracket. So maybe this bending thing may be useful this time. This used to be very difficult to get in here. Okay, I'm going in the C when I'm supposed to go in the L. Go in the L. Just kind of feel your way down there. Okay, I'm trying to get it to engage now. Seem to want to engage with the screw. Huh. Oh, I think I got it right there. Okay, I'll watch the meter now. No, it's not in the screw. If anything, it's camming out. Okay, it's kind of what I thought it was. So the capacitor tuner is a screw head. Easy to put a screwdriver into it. The other adjustment is one of those, threaded shafts with a split at the top, and you've got to get your tool to come in and hit it right on the top. And what's happening is the tool is slipping past it, going deeper in, and then it's kind of in here where it feels like it's engaging with something, but it's just jamming. It's just jamming up against a different stuff. So in order to get this to come on the top, I'm going to use a tool like this. This one, the blade is recessed, so you can fit it right on top. Once you get it on and engaged, it sits there. It doesn't come off. This is the tool. I'm using the best tool. So now I'm going to stick this. The reed is still operating. Yes. Okay, I'm going to stick this down the L. You have to do this for every band. There we are. Oh, I got it. I'm in. I'm definitely in. So, are we set here? So we're at 5.6. 5.6 on here. Watching the meter. Up, 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 down. So here. Now the C. I gotta go up to the other end of the band for the C. We're on our way to 1.3 megahertz. 1.3. Oh, what's that? Wow. So we're at 1.1. So if you take 560, add 450 to it, you get 9. You get come on, 450. 9. You get 1,010,000 or so. This is roughly where this is. 1,010,000. It's not 1,010,000. That's 1,010,000. Well, it's got to be an image of some sort. That's horrifying. What's happening here? The signaling feeding into the antenna is not that great. So it's hearing 560, basically at double that frequency. That's just not right. Well, maybe I'm hitting it with just too much signal, because I am too. I'm doing an alignment, or I should have the signal way down. So it's still there. Oh, certainly more alignment stuff to do. I didn't do all these. Oh boy. Is it lunchtime? It's getting close to lunchtime. It must be low on calories or something. Right on the 560. Still on the 560. Do the rest of the tune-up, Chad. Oh my gosh. Okay, so I kind of started over there. I had the selectivity control too far open. It's supposed to be on 3. I didn't have it right. So I'm just redoing them now on the second L. Oh, that's pretty distinct. Okay, and we do the third L. Yeah, I'm gonna have to do this like 100 times. There we go. Got it in. Down, up, and down. Right there. The last L. Now, the last L. Isn't it affecting the oscillator? Watch what happens. Oh boy. So I think that's the oscillator. I should start with that, shouldn't I? Shouldn't really start with that. You should start with that. Don't think the instructions declare that. Normally you do the oscillator first, then the rest to match. Going back. Can't see a real difference on that. We are on the lowest band here, so maybe that's part of the picture too. Right at the bottom of the AM band. Come on, man. You can go in there. There we are. I can't see this. Fractional change, I can't see this being. There we go. Down. Down. About there. Okay, now we go up to the high end of the band here. What frequency are we shooting for now? 1.3, right. It's just picking up noise in the shop, I think. There's 1.3. There, dial up 1.3 over here. Okay, there's 1.3. Just tuning the big dial here. That's a spot. Great. I'm going to do the oscillator first. Makes sense to me. Happening is I'm not really engaging with the screw, but I'm able to move it a touch. I'll try the big bad screwdriver now. Okay, so the screwdriver has an effect on the capacitor. I went in there, so here I'm in. Okay, I'm ready. Here we go. Wow! Okay, this is a hair trigger. Okay, listening to the tonal quality. That would be the spot. There we are. Do the rest of the C's. Some hot tubes up here. A lot of trouble getting that in there because of the interference of this bracket. Bracket's in the way. This isn't got a nut underneath. Oh, it could have a nut underneath. And the nut's going to drop. Oh, if it has a nut. No, there's no nut. It can't be a nut. Let's take this out here. Is it going anywhere? I don't think it's going anywhere. Okay. No tipping the transformer over, or the radio over, because the speaker. Yeah, I've been doing this for a long time. We should be able to get in there. We're in. Okay. At the high end, everything's ready. Watching the meter now. Oh, that is fine. Okay. C's again. Did I do them? I can't remember. Hot tubes. They're all pretty close. There you have it. AM band aligned. Let's check it out. Okay. Well, 680's coming. Well, we can't see it on the camera, and I may not be able to get it visible. Oh yeah. We're listening to 680, right on 680. Oh, there's some interference. We're going to fool with the radio on this.
For like 24 hours.
So first, we want to figure out, is the interference on the left or the right?
So we put it outside in the garage, and
it's on the left. Tune in the signal you're after.
As a kid, I had no patience. I still don't.
And move it a little bit away from it.
I can't wait that long. I could be dead by then.
This is one way to get rid of it.
We'll be right back.
Got rid of it, but the signal got too weak. Okay, so we'll come back. We'll make the selectivity smaller. Still here. The sound's not good enough. This might not work. I'm going to try to knock it out with this. It did work. Okay, so now we're tuned right on the actual signal, not off to the side.
But financial support is available from the Government of Ontario, from grants of up to $20,000 for eligible small businesses to support for purchasing PPE, to rebates for property tax and energy costs. We are working to ensure our small businesses can keep employing people and serving our community now and when COVID.
You got to think for a moment. When I turn this wheel, how far those big capacitors we saw up here are moving. They're completely imperceptible movements when I'm doing this. Yet,
About COVID itself.
this is what makes this radio fantastic. It's exactly this tuning. So you've seen how the phasing control can work to knock out adjacent signal interference. Typically though, this would not be used on a voice so much that you'd be trying to pick up some kind of digital signal or something, a teletype or something like that. Then you'd stop way down here, and normally you wouldn't have this down this way. Up like that. See the difference there. 610. Another thing that's fantastic about this radio, makes it a great cruiser radio, is I'm on 610. That's 620. No, there's no station there, but at night there's probably something there. And I'm able with this radio tune in between and hear neither if you have it set right. It's if they're really strong stations, yeah, you'll hear them. But if they're some distance away and kind of moderate signals, you can tune between them. Show me another radio that can do that. That's 590, the sports channel. No question of what frequency you're on this band. You can read it directly. No, there's no question. Excellent. Alignment is excellent. Very good. That's one of what? 1, 2, 3, 4, 5, 6 bands. So I got 5 more to do. I'm going to spare you the torture. The fact is, when I'm shooting these videos, and I'm conscious of the video thing, it's just too much of my brain sliced off for that purpose when I'm trying to concentrate really heavily on not making a mistake doing the alignment. So that sounds like an after lunch thing for me. I'm going to leave the radio on so it stays nice and warm. I'm going to complete the alignment and we'll see what we get. Okay, I think maybe what I'll put on video is the accuracy of the radio before I do the alignment. So this is based on my previous alignment efforts over the years. So I've got the signal generator on 1400, and here's where the radio picks it up. Well, pretty hard to improve on that in terms of oscillator. So I set it right on 1.4 here. Okay. Very, very close. So I'm going to just, well, we should go up to the other end. Well, let me align this, then we'll check the other end and see how it is. Okay, so I have the signal generator set for the high end of the band here, 3.4, and we will head up there and see what happens. Okay, so I'm going to do the C of the oscillator to bring it in here. C of the oscillator. Okay. There it is. Here we are. Excellent. The signal generator back at 1.4. Dead on. Okay, that pan's done. On to the next one. Okay, so I just did the oscillator for 3.75. Okay, so I'm going to do the rest of the L's for this band. Okay, I'm at 7.15 megahertz. We'll tune the radio up there and just, once again, how good a job did I do last time? And how, you know, has it hung in? The word is, this receiver should remain aligned for a long, long, long time. 7.1. 5. Can't complain about that too much. So what I will do is I will do the I'll leave the oscillator alone, it's fine, and I'll just do the other C's. Away I go. Okay, so we're dialed in now 7.5 megahertz on the signal generator. Here we are on the radio. Doesn't seem to be there. Let's hunt around for it. Oh, there it is right there. Just a hair off. So put it on. We're at the low end. So I'll do the oscillator L. Here. I think I'm in. Yep. Okay, while I'm doing this, of course, I'm watching the output meter. Okay, that's good. Okay, and we'll carry on with all the other L's. Most of the time when I've been making these adjustments, there's been virtually no improvement in the meter. But here's one. This is the so this wasn't 100%. Let's just check another one. Another L. Oh my gosh. This is way out. It's a really important band. Shame on me, but this is why I'm doing this. Oh my gosh, another one. I'll turn this down. Oh boy. Way out. Okay, is there something going wrong? Am I doing something wrong? 7.5, and we're dialed in on 7.5 on the radio. Wow. Okay, I just did a bad job on this one last night. Excellent. Okay, so this same band we do at the top 14.5 megahertz. Let's dial that in here. What did I say? 14.5? There we are. Here we come. It's off. It's very weak. Oh, I did turn the signal down, didn't I? Do a little more signal. Okay, where will we go? So this will be C of the oscillator. C of the oscillator. Get the right tool. Okay, I'm in. Here we go. The other way. Where is it? Maybe that was it. Yeah, that's it. Wow. This is a little bit of backlash in this one. Went past it. Oh. So this is why you want a really stiff tool, like this exact problem here. Very, very sensitive. Well, how accurate is it? I knocked this off 14.5 somehow. Okay, so we're dead on 14.5. Okay. I can't find it. Oh Lots of backlash in this one. A little tiny piece of metal is too much for it. Let's try this. I don't know if this will go in. There it is. I'm in. So what's happening here is this is sensitive to everything from pressure, just to everything. So how accurate can I get this? I mean, it's really close now. It's really close. Let's call it a day. Oh! Not so close now. Okay, going in on the C here. It's just a tool moving around near. This plastic tool affects the. Holy smokes! I thought there's no way a plastic tool could do that. I'm just waving it in and out of the. And that's the screw head. We're in. We're in. It's definitely stiffer. I think it's tuned right on yet. You just kind of play with it till it ends up in the right spot. Oh. Okay, this won't stop in the right spot. Oh, that's pretty darn close there. I don't know how I can make it any better. Okay, rest of the C's now. Somewhat inconsistent with how I've done the video. Let's try this big one on the C up here. Down on the input here. So that was a little out. Next C. Okay. Ho ho ho. Bad job done. Before. Down on the volume this time. This is going to make a dramatic difference in the operation of the radio, I'm sure. These things are additive, you know. Each one's getting a little bit of a boost. Now, yeah. The radio could have been properly aligned somewhere else, you know, for a different local oscillator frequency. It'd be just fine. And all I'm really doing is moving it from just fine to just fine in another place. If I can get this to come in. This is a terrible tool to use. Here, look. The screw hasn't moved. Look at how far I got the screwdriver to turn. It didn't even move the screw. It's just putting pressure on it. I really do need to use something like this. So a poorly aligned radio can be compensated for by turning up the volume to a fair degree. Wow, I can't believe how... Let's knock this down. 10. Last time I aligned this radio, about 5 years ago, I don't think I ever said anything about it, but at the end of the process I said to myself, I'm not ready. And so that's why I've waited another 4 or 5 years of experience to try to do this again. Not that it's difficult to do, it's just so easy to make a mistake and not get it exactly right. That looks pretty good to me. Well, and right now we're listening to around 10 microvolts. I haven't calibrated the signal generators we've gone, but it's quite low. There's no doubt about it. It's very low. Next band. Okay, so I find stuff like this quite annoying. So the frequency is 14.5. I'm dialed up on 29 megahertz. What is it you find annoying? I found something annoying. But I went the wrong way this time. Oh. Well, that's pretty annoying because that's 29 megahertz tuned in and we're listening to 14.5. 14.5, you double that, and guess what you get? 29. If there's an actual signal, if I'm listening here at 29 megahertz and there's a signal on my antenna at 14.5, I'm going to hear it. That's not right. Okay, I'm going to get the real 29 on here now. It's really quite upsetting that happened. You would think it'd be almost impossible. 29. Okay, that's 29. Close. Okay, I'll do the C on this band on the oscillator. A little low on light here. Oscillator, high end doing the C. Oh, what happened there? There we go. Okay. Oh, it's probably a hair trigger here. I have the same problem again, even worse. I've got to guess. I've got to like tune it for my tool being out. I'm really running into the flexible thing here. It's really... I wonder if it's a tube and stuff. 29. There's nothing up here to listen to anyway at 29. CD. Come on. Oh, I thought I had it there. Wow, it's way up. It makes a big difference moving this tool. I can't believe it's that sensitive. How did I ever do this with a sewing machine? A screwdriver. I didn't do it at all. The other way. Just didn't want to make it there. Never did. Jeez. The whole time it has not moved a bit. If anything, it's gotten worse. What is going on here? It just jumps back and forth around the key spot. I'm gonna have to just accept that. Okay, let's go down to the bottom of this band. I've got 15 dialed in there already. We'll see what happens here. When I did the C's, the capacitors, it didn't make a big difference again. The radio was pretty good. Here we go. Seems a little weak, eh? So, give it a little more. You can hear the tone. Very weak. Okay. Well, that's what we're here to fix. So, first of all, oscillator, L oscillator. Again, just on my hand. Jeez, what is it about these plastic tools? Why do I stick a big metal tool in there? What happens if you do that? It's even worse. And this other plastic tool has an effect too. Well, I'm very surprised about that. I think I would have been easily convinced that plastic can't possibly influence these signals. So I'm trying to get in the L here. There. Now it's drifted off because I put the tool in. How far? That far. So that means the tool means I should align the radio slightly this way. Normally I can't see this kind of precision. I got a camera zoomed in on it, but this is, I normally see it with this kind of precision. Let's do that. And conceivably when I pull the tool out, it'll be right on the money. Okay, I'm now going to turn the tool. My signal disappeared entirely. Okay, we'll try with this. That's not the signal. There's the signal. God, you're supposed to be doing this with 20 volts on the output. I'm doing it with not even 1 volt. I can't imagine that matters. It's probably just more convenient to do it at 20. This guy tunes up nice. Oh, no he didn't. Let's just see what we ended up with here, because maybe it's not worth worrying about. Oh yeah, no, that's right. When I pulled the tool out, I expected it to drift. 15 is where WWV is, so it would be very impressive if this would be dead on 15. I'm adjusting it again. Pulling the tool out. Checking it. Wow. Can't complain about that. Okay, so I'm going to do the rest of the L's now. Here. This is a 15 megahertz to do a lot of shortwave listening there. Rest of the L's. Okay, here we go. Oh my, look at that. Jimmy, what have you done? Hey, this has hit the end of the run here. Right near the end of the run for this adjustment, but not quite. Okay, yeah. Everything right? 15, yeah, everything's right. Okay. There we go. This one's out a little bit too. And then the last L here. That one was right on. One more band to go. A band I almost never use. This is the. Okay, up we go. Let me stop for a second. Okay, so we're set to 30. Now this top band, 30 to 54, I virtually never listened to, and I'm not even sure it even works particularly well at all. Let's find out where 30 appears. Jumping around, eh? Well, that's right on, you know. There's no way I'm going to make an improvement to that. So, even though this is jumping all over the place, that's a 1 microvolt signal, or even less, coming at the radio right now. So, that's not too bad. I was able to peak the hiss, and I think it's valid what I was doing. He's jumping at almost a meg. Come on, I can't possibly do this. Yeah, just too unstable. So, okay, don't use the radio up at this height anyway. This height. So I think that's going to be it. Time to have a little listen. see how we've done here. I heard something there a couple of times. That's not very good. There's 20. You know what? I haven't heard WWV on 20 megahertz in ages, but it should be right on the 20, shouldn't it? Still impressive that I'm hearing it, especially here in the shop.
Part of David in Ethiopia, which features Bedouin music performed by other artists. Ethiopian
Radio China.
presents a window into the long history of Ethiopia, revealing cultural efforts in bringing back
20 decibels on the S meter. Uncalibrated. Terribly uncalibrated. WWV 15. That's probably it right there. See if we can dig it out. Dirt here. Oh, that could have been affecting the alignment. Oh, I lost him. So that we were hearing, the Oscar, Delta, that stuff. So that's an American military broadcast just above 15 megahertz. When they have a net, I believe, maybe a worldwide net for communications purposes, and they exercise it all the time by doing this. They come on and they you know, Oscar or Delta, this and that, and that's just to keep everything operating and working in case they need the communication system. I'm sure a lot of you know a lot more about that than me, but that's what I'm pretty sure that was. So we didn't get WWV. Surprising, because we got it at 20. Now let's go down a band. So we're at 7.5 megahertz. Okay, and we're going to go up to 3 kilohertz bandwidth.
Ready face on November 3rd. Power ground. Still, the cataclysm.
In one, they closed down much of the U.S. economy and then printed some $4 trillion fake dollars to protect people from the economic damage. And we're getting used to it. Here in Argentina, for example, we have been locked down for 7 months. A permanent roadblock has been set up near here. Each time we go to town, we are expected to tell the police where we are going and why, as well as have a travel permit ready for inspection. It almost seems normal. Recommended link. Buffett goes on. A Wall Street legend has just made a rather large discovery. For the past several months, he's been tracking Warren Buffett's top 25, and what he found was surprising, to say the least. 21 of Buffett's favorite companies are going all in on a hot new technology, and a total of $1.7 billion. This is remarkable because Buffett is notoriously anti-technology. In fact, he once joked about shooting down the Wright brothers' first plane at Kitty Hawk. So, what is this new technology? And why are America's biggest companies all in a race to implement it? To get the full story, watch this stunning new presentation. What is Buffett's big bet? Click here for full details. Dash. Fact of life in the U.S. 2. Normality dives to the downside to escape the threat.
The normal bandwidth can't even listen.
Requiring temperature checks or
Stop
COVID
it down.
tests before entering a
Get rid of all
public
that
building,
noise.
even though they did nothing to stop
Better
the
signal
virus
to
in the
noise.
White House. And the fake money, that's becoming a fact of life. 2. Unlike the virus.
The fake money? What? I don't want some fake money.
Soft tissue of the brain.
Oh my gosh, it's almost 1 o'clock. If we're lucky, we could pick up some airplanes flying over the Atlantic. So this is a time signal from Ottawa, Canada, Ottawa, Ontario. That's about 300 kilometers from here. Kind of weak, eh? I really aren't going to listen to it. I know what time it is. It's lunchtime. I'm going to flip to manual RF. Actually, it's not much difference. ADC off. Start hearing some international broadcasts here. I would think. No? Hold tight. But no international broadcasts. Something funny going on with the sun? Yeah, there was one there. But we're going to go up to 11. Go up a little higher here. Oh.
María Teresa Minero es comunicadora por excelencia. Además, trabajar como profesora popular programa de la televisión cubana. El libro y la música y el pueblo de Cuba.
Toledo. Ahora sí.
Oh. That's a dangerous level of carbon dioxide I see there. Owen, give us the reading.
Yeah, it's actually about to go off the charts, it looks like here, Alex. This thing doesn't go higher than 9,999 parts per million, so I think we're about to go off the meter here, Alex. Yep, there it goes.
So we're about to go. How you feeling? Do you feel like you're being suffocated?
Yeah, I can
Can we show the Godfather 2, Godfather 2 smothering scene? Just type in Godfather 2
This is
smothering
Alex
scene.
Jones.
Or Godfather 2 assassin scene.
I don't
The guy's
know. Yeah, I mean, this is probably how the Judge Scalia felt in his last moments, I would imagine. But
or Jeffrey Epstein.
I really cannot breathe in right now. I mean, it's like
I don't care. You're a terrorist. You're going to wear at least 3. Let's go further. Put the 4th one on. Do it or you're a terrorist. They're saying they want to charge people with terrorism but don't wear more. That'll just pour like glue down your throat, Jim. Why don't you just kill yourself so you don't spread COVID, you dirty human? How's that feel?
I think if I wear it long enough, Alex, you'll probably
Oh my gosh. I listen to things like that guy, another guy. I listen to religious broadcasts specifically to know what is going on, not to understand or join in what they're saying. I just like to be aware of all the stuff that's going on that the average person may not be aware of at all. On shortwave and on the internet and all that other stuff. Yes, there's a lot of stupid stuff going on shortwave these days. It's a European band coming up here. Cuba.
And a way of day. Prove you this day whom you will hear. Believe, obey, do what you're told to do. That's how you can know. You can exercise what you call it is free will. If you will to do God's will, then you will know. You will be understood.
No ham radio? Oh well. That's the FT8 or FT4 on ham radio. No Morse code. Okay, I think that's a pretty good check here right now. Oops, not doing the right thing here. Come on, there we go. Okay, so the radio appears to be working really quite well, and I think I really need to test it out at night, in the evening. Now it's working really well. Now I want to perform some experiments with it. That's what's going to happen in the next video. And nothing heavy, just some light experiments. So thanks a lot for watching all the way to this point, and we'll have some fun with it in the next video.